Hey, my name is Ben. Thanks for stopping by. I appreciate it very, very much. Today we're going to be installing a 100 amp subpanel being fed from this main panel right next to me here. This is going to be a pretty detailed video, so go grab a cup of coffee and a pen and paper if you want to take a few notes along the way with me. Whenever you're going to be adding a subpanel, always add the largest panel that is practical to add. Or if you were thinking that you needed 6 circuits, make sure you put in at least a 12 circuit, because you're always going to need more than you thought you were going to need. So let me show you what came with this particular subpanel that we're going to be installing. This is called a main lug panel in that it doesn't have a separate main breaker. You do not need a separate main breaker if you are in the same building as the panel that you are feeding your subpanel from. If you are in a separate building, you only need a main breaker to disconnect the power if you have more than 6 circuits inside of that panel. The concept is that you want to be able to turn off all the power very quickly in a separate building, so having a main gives you one spot to do that, or if it's less than 6 breakers, you technically don't have to have that main breaker. Also, that breaker doesn't have to be the same size as the breaker that's feeding it. So a lot of main panels, like if you were to buy a 100 amp panel, it'd have a 100 amp breaker. Well, you could feed that panel from a 60 amp breaker inside of wherever your main panel is, and that would still be fine. You're just using that 100 amp breaker as a disconnect means in the separate building, or in the same building for that matter. And it doesn't have to be another 60 amp breaker. As long as you have the correct breaker feeding the panel, it's fine. So I'll show you what came with this panel and a few of the accessories and things that you're likely going to need for getting your 100 amp panel, or smaller depending on what you're doing, set up and ready to go. Here's the exact panel that we are using today. I'll try to link to it in the description below, or at least something that is very similar. Of course, it comes with your standard cover, and then it also comes with a few additional accessories. This particular kit included a couple of standard 20 amp breakers, and then it also includes the separate grounding bars, which is really nice because if you are setting up a subpanel, you're going to be separating the neutrals and the grounds. So it comes with those grounding bars, so that's fantastic. They also leave the bonding screw out of the panel, so you only install it if you actually need it. We'll talk more about the bonding screw a little bit later in the video. And then of course they include the screws for installing those ground bars, as well as the screws to hold on the panel cover. Then of course we're going to need our feeder wire coming from our main panel over to our sub panel, and in this case we're going to be running 3 gauge copper. That is well adequate for running 100 amps, which is what we're going to be doing today. So since this is a large 3 gauge wire, they actually don't make this in multiple colors. It just comes in black if you're getting the THHN type of wire. If you're using 6 gauge or smaller wire, you can actually get multiple colors, and you will have to get the correct colors. And if that's the case, then you're going to need to make sure that you get white wire for your neutral conductor and then 2 black wires. In this case, since it's a larger wire and it only comes in black, you need to get yourself some white electrical tape, and then you're going to mark that neutral wire coming into the panel as being a neutral with a piece of white tape. That's allowed according to the National Electrical Code for any conductors that are larger than 6 gauge. And then we have our grounding conductor, which is a 6 gauge bare copper. In this case, it is a stranded wire. Then of course you'll need a 100 amp breaker for whatever style panel that you did choose to get. This will be what is feeding our main lug panel. When you are selecting the breaker that you're going to be using and also the size wire, you need to confirm the temperature rating of the terminals. So here are the terminals on this 100 amp breaker. If you look really closely, you can see right here it says number 12 to 2 gauge aluminum or copper, and then 75 degrees Celsius. So this is rated for sizing your wires in the 75 degree column. So that is an important thing to be able to tell, because otherwise you'd have to use even larger wires, but since it's rated at 75 degrees here, and then you want to make sure that it's rated at 75 degrees on the panel itself, which if your panel that you're using is rated above 100 amps, it's going to be rated for 75 degree conductors coming into its main feed by default. So as long as you can see that 75 degree marking on your breaker and your panel is greater than 100 amps, then you will be good to go for using that 3 gauge copper wire at 100 amp rating. And then we're going to be using just 1.5" PVC conduit to connect the 2 panels. So we have a long sweep 90 2 male adapters, and then of course you'll need some 1.5" PVC itself, a coupling, you'll need your lock nut to hold the male adapter in place, and then a bushing to go on the end of that in order to prevent the wire from getting damaged from the sharp edge of the fitting. Then you'll just need a can of PVC cement so that you can put your conduit together. You do not need to use primer when you're working with electrical conduit, but you do need to glue the fittings. So we're going to be mounting our sub panel about right here on the wall, where the top height right here is lined up with the other one. And so we have our circuits that we're pulling back to this area. So we're going to let that actually extend down past the bottom of the sub panel, a couple feet, 2 or 3 feet down below it, and just give ourselves plenty of working space with our wire. Now when you go to mount your panel, make sure you pay attention to the clearances that are required for your panel location. Make sure that you have a good 3 feet out in front of the panel with no obstructions, and then it's good to have a good 3 feet wide as well, just to be extra safe. So you want to have a big square space that's totally open. It's fine if it's in the same area as another panel. You just have to be able to open the panel door 90 degrees for sure. So we've held this one out away from the wall a little bit, about the same as this original main panel was. Now as far as the height of the panel goes, I believe it's that you can't have any breakers more than 6 feet 6 inches off of the floor. We're well within that. 6'6" is way up here, and we have the top of our panel set at 6 feet, so the actual height of the handles will be like 64 inches or less. So just mount the top of your panel at around 6 feet and you should be fine. So we're going to run our conduit in between these. I have the hole here at the top of the panel where we have an 1.5" knockout lined up to the same height as the one on our main panel, so we can just have a nice clean piece of 1.5" PVC bending around that corner. Now before working in the main panel itself, we're going to turn off the power to the house. For now though, we're just going to be opening up that knockout and pulling the conduit in, so we should be okay. That's not okay to say, is it? Anytime you're working inside of a panel, you want to do as much as you can to get the power totally off. Now you usually can't get it all the way turned off with a main panel like this. These top lugs right here are always going to be live because those are coming directly from the meter. But we can still do our best. So what I'm going to do here is I'm wearing insulated gloves, rubber-soled shoes, my safety glasses, and then we're going to go ahead and turn on some temporary light, and then we're going to kill the power to the rest of the house while we take out this knockout here. So now our power is off to the house, and we still have the power feeding to right here, so we got to be mindful of that. But everything down here should be dead, but we're going to treat everything as if it were live. We're going to be super careful because that's what we're supposed to do. Otherwise the safety trolls will tar and feather me. I went ahead and marked which knockout is for 1.5" so that I don't accidentally open it up too big. Put this in here so that we can get everything kind of dry fitted. Now that I have that first fitting installed, I'm going to turn the power back on so that I have better light. And anytime we work inside the panel itself, we'll do our best to turn off the power again. When you hang up your panel, make sure to use all of the factory anchoring points. There's 1, 2, and then there's 2 more down at the bottom. You can use this teardrop shaped anchor point right here temporarily to hang the panel and kind of get it hanging square, and then put your final anchors in both at the top and the bottom. You always want to dry fit to some extent to make sure that you don't glue everything together and then something is too long. So I'm actually going to trim a little bit off right here, but I do know my final length right over here, so I can take that measurement. So we'll cut that last piece and trim this, and we should be ready. I like to take my utility knife and just clean up the inside edge of each fitting after I'm done cutting it. Just kind of gives it a little bit of a chamfer so that it's not so rough for any wires that you might be pulling through the conduit. And then the same thing around the outside edge, kind of scrape it like this. Stuff is always hard to open at first. A little bit. If you're looking for a great gift for somebody, Knipex makes the very best channel locks. I'll put a link in the description. So I want to make sure that we glue all of our connections. This stuff smells pretty interesting. Give it a little bit of a twist as you push it in. It is always best to put the glue on both the female and male ends of the connection. Then kind of just test fit it. You want to just hold it for a few seconds after you get it glued up. That should do it. Up next, we're going to be installing the ground bars into the sub panel itself. This part is pretty simple, and it's especially nice since this particular panel actually came with the ground bars. If you have a panel that doesn't have a separate ground bar, then you can purchase one. They're inexpensive. I think they're less than $10 typically. I will link to the different ground bar options that you have in the description below. Now, before I forget, I'm going to finish mounting the panel in here with a couple more screws here on the bottom so it's not possible for us to accidentally bump it off of the wall. They actually give us quite a bit of flexibility for where we want to put these ground bars. I'm going to put one on either side, obviously, because for convenience sake. I think I'm going to put them kind of down towards the bottom right here. So this first one I'm going to put on the right side because it has the main lug for attaching our copper ground wire that's going to be coming in here. So I'm going to put that right there, and then I'm going to put the other one on the other side, just kind of mirroring it. So you can see how there's these nubs that kind of stick up a little bit, as well as these holes. And with that, you can actually mount this over two nubs with one screw in the middle to hold the grounding bar in place. That's not my preference though. Personally, I'd rather use two holes, and either one is acceptable. So I will be lining this up with these two holes on this side, and then the same thing on this side over here. Right here you can see what I'm talking about, either two nubs and a screw or just two screws. And we're torquing the screws down to 30 inch-pounds, which I can precisely feel with my hand. Now, even though these two ground bars are on opposite sides of the panel, you don't need to run a wire between them to connect them. The casing of the panel is adequate to connect the ground bar from one side of the panel to the other, even though our main grounding connection is only going to be on this main lug right over here. Now we'll take and attach our little grounding labels next to each ground bar, and this sticker gives us our specifications on what size wires this particular grounding bar can have connected to it, which is really handy. So we'll just talk briefly about the bonding screw here again. They include the bonding screw because this panel can technically be used as a main panel. If this was the first panel in the system, we would have our bonding screw inserted right here, and that would tighten down and connect the casing of this particular panel to the neutral bars, which in turn would connect it to the ground bars. You don't even need the ground bars if this is your main panel, because these act as your grounds and your neutrals. But anytime you have a sub panel, you are not allowed to bond the neutral bars to the casing of the enclosure. You have to separate your grounds and your neutrals. So only neutrals can land here and only grounds can land over here, and we have to make sure that we have our bonding screw removed. We'll take a quick look at our main panel right over here, and I'll show you how the bonding screw is still installed and the way it's set up in here. So you can see right away in this main 200 amp panel that there are both neutral and ground wires that are attaching to the neutral bar. You can see there are a bunch of ground wires there at the top, but then you go down further and there are more neutral wires. There is also no separate grounding bar anywhere to be found in the panel. You can see right there that green-headed screw, that is the bonding screw. It is still installed, so that's a dead giveaway that this is a main panel and not a sub panel. Okay, up next we're going to be pulling the wires into the sub panel from the main panel. So we'll be running our 6 gauge ground wire and our feeder wire next. This is 3 gauge, like I mentioned earlier. Anything 6 gauge or smaller, so if you're going to do like a 60 amp subpanel, you need to get 2 blacks and a white. In this case, they don't even make white 3 gauge wire, so we're going to redesignate that, and I'll show you how to do that in a little bit. It's nice if you can find a place that sells this stuff by the foot. I got this at Home Depot, and I think it was like around $1 a foot for what I needed. So it really was only about 20 bucks worth of cable. I think we got like 16 feet, plus then the ground wire was like $5 or something like that. So I'll link to this stuff in the description if I can find it, but you might be better off going to some kind of a home center to acquire the wire that you're looking for. And since we're going to be working in our main panel again here, we're going to go back to wearing our safety gear and cutting the power off. Now 6 gauge stranded or solid copper is adequate for a 100 amp sub panel. If you want to be a little bit overkill, you can spring for the 4 gauge wire, the 4 gauge copper wire. It's not going to cost you that much extra, and it's always better to oversize a little than to undersize. You can fit typically up to a 4 gauge wire into these grounding bars, typically, without having to add a special lug adapter. We want to keep our ground wire way in the back of the panel, always. Again, we're being mindful of the fact that these are hot still. Oftentimes panels don't have these yellow protective covers, so oftentimes you have that exposed conductor that has 120 volts each on those 2 legs, so just be really careful around that stuff. And loosen the screw that we're going to be putting our ground wire underneath. You can kind of see the difference right here. This is a 6 gauge, and then this wire coming in to the panel here for the grounding wire is a 4 gauge. Get that good and snug. The torque spec is 35 inch-pounds. Now inside of this panel here, we will feed our copper wire down through our grounding lug. And it says right on the side of this terminal here, it's good for 6 to 2. So we'll tighten this down really good here. Now technically I could just cut this wire off right here and leave it at that, but I have this extra bit of wire here, so I think I'm just going to actually roll that across the bottom and connect it onto my other ground bar. It's redundancy, it's not absolutely necessary, but it's not going to hurt anything in the sense that it's going to just provide a little bit even more continuity between this ground bar over here and that one, in addition to just the casing of the panel. Again, not required, but we're doing it because we have enough extra material. Anytime you're working with stranded wires, always wiggle the wires a little bit and then retighten the connection again, because it tends to flatten out the wires and you will then be able to get a little bit better connection. So I have this big coil of wire. I'm just going to take both ends of it and feed them through at the same time. So we'll just feed these through over to where our 100 amp breaker feeding our panel is going to be located. The 1.5-inch conduit is about perfect for this application. Just going a little bit larger on conduit isn't going to cost you anything extra, or not very much, and it's going to give you a lot more flexibility, just being able to pull things through the conduit with ease. So 1.5 inch is perfect for this application. I'm pushing these wires back so that they run all the way up against the back of the panel. Alright, we got them through. So we're just going to be stripping this 3 gauge wire here now. So I'm just going to take my utility knife and I'm going to go back about 1/2 inch here. And I'm just going to lightly press. Then I'm just going to rotate it around. I'm just going to make one cut down the length of it here. That should pop it free and peel it open just like that. And right here is our 100 amp breaker, all ready to go. So we will go ahead and attach those to the breaker before we install it. Now again, with this being stranded wire, it's a good idea to do this. Wiggle them back and forth. And then you'll be surprised at how loose they feel. You can crank it down again. And then we'll repeat the process 2, 3, maybe 4 times to really make sure that those are seated in there well. So those connections look great, nice and tight. We can push the extra cable back that way. Be careful not to use the breaker as your leverage point. Grab the wires themselves as you work it into position. There it is. All right, snapped in place. So with these large feeder cables, we really don't need to leave them any longer than they need to be. So I'll give myself a little bit of extra in the sense I'm gonna push this loop up a little bit, but then we're just gonna cut it off right where we need it to be cut off, which in this case is right about here. Take our Knipex side cutters and clip it off. Woof-da. Now I'm pushing our final conductor through here. This is going to be our neutral wire. Now in order to land that big wire onto the neutral bus in our main panel, we actually have to use a kit, a neutral lug kit to install right there. Right here is what the kit looks like. You can see the model number right there. I'll link it in the description below. So we're going to need a few of these terminals here in a row in order to install this little kit here. So I'm going to have to move these 2 or 3 ground wires down as well as this here neutral. So we do have 4 here in a row that are available. So we're just going to pull those screws out for now. Here are the components that come in that kit. We'll start by mounting this here little plate on to the neutral bus using one of the 2 included screws, and then we can slide this down over the top of it, get it kind of close. Hey, Amelia? Don't sing right now. Okay. Now we take our little screw and drop it through this like so. And now we're ready to attach this on top of that bracket and tighten it down nice and snug. And now our neutral lug is attached. So I'm trimming this cable to length here, so we'll be ready to land it onto that neutral lug that we just added. Now since that is in neutral, we're going to have to mark it with some white electrical tape. I'll link to this stuff in the description. Then we'll just wrap the cable couple of times up where it will be visible, and then we'll do the same thing on the opposite side. Now we're ready to make our connections, and then we'll just tighten that down, being careful not to over tighten it, of course. Wiggle it, tighten it some more, wiggle it, tighten it some more, wiggle it, tighten it some more, wiggle it. We're getting close now. That's it right there. Good and tight. And we torque that down to 75 inch-pounds. Alright, we're going to take our neutral wire here and finish landing that inside of our sub panel. See how we have it clearly marked with the white tape indicating that this is a neutral. And tighten it again. So there we have all of our main conductors brought into our sub panel. Now we're going to bring a wire down into the top of the panel, but first I have a quick question for you guys. A lot of times you see panels that are just hanging on a piece of plywood with the NM cable, or the just regular old Romex, stapled right to above the panel itself. In my opinion, that's adequate, but in some areas they require this conduit going from the top of the panel up to the joist cavity. So what I want to know is, what is most common in your particular area? Click on this poll right here and let me know. Do you run conduit from the top of the panel up to the ceiling, or do you usually just staple the Romex right to a piece of plywood? So for the runs going up above this panel right here, we're just going to use a couple pieces of 1/2 inch PVC for the standard Romex that we're going to be pulling into this panel. Now I already have these cut to the right length. I'm just going to take my utility knife and create kind of a chamfer on the inside edge of each end of these. That way, with the wire protruding from the top of this piece of PVC, the jacket's not going to have a really sharp edge that could potentially damage it. So you just run your utility knife along the top, just like this. So there we have our conduit ready to go. We'll just knock a couple knockouts out for our conduit. You can pretty much just use a screwdriver with your hand and just one firm tap. That kind of pops them down. And then you can just use your fingers pretty much to bend them back and forth until they come free. Make sure that you wear gloves because these can be pretty sharp, depending on. Take my conduit pieces, slide them down into position. Then we'll just go ahead and put our lock nuts onto our pieces of conduit. So I think we'll finish out this subpanel by wiring in our first circuit that we have pulled in so far. There'll be a bunch more circuits that we'll be adding as time goes on. This is in a project where the basement is being finished, so there'll be a couple bedrooms, living room, bathroom, and stuff like that that's going to be pulled into this panel. For now though, we just have this one, so we'll go ahead and wire it up. We'll just be using our utility knife to strip the length of this cable and very carefully keep the blade right in the center of the cable where the bare ground wire is. And we're going to make sure that we also have a good, let's just call it a ½ inch of sheathing that we leave exposed inside of the panel. Pull the cables up and then push the sheathing back and cut it just like that. Provides a pretty clean cut. So as always, we'll start with our ground wire first and then route that to where we want it to be. And we'll bring it in right at the very bottom screw. I like the ground wires to be all the way back tight into the corner. And we'll trim that to length. Now we're going to be using an arc fault breaker because this circuit is going to be supplying a bedroom and a living room for general receptacles. So with this arc fault breaker, it does have the pigtail. So we'll be landing the pigtail onto that neutral bar. Both our black hot wire and our white neutral wire will come straight to this breaker. They do make a breaker that has the plug-on neutral, so the plug-on neutral version of this, where you don't technically need the pigtail. The pigtail's not that big of a deal, so if you're shopping for arc fault breakers, I'd recommend just picking up whichever one is cheaper. I'll put links to both in the description below.
Fire. 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 Warning, carbon monoxide. Fire. Fire.
We're going to bring the hot and the neutral wires over to the back corner of the panel, as again, the same as we did with the ground wire, except that we're going to run these down and put a loop into them and then bring them back up again to our circuit breaker. And what that'll do is just give us a little bit of flexibility if we ever need to do something different with these wires in the future. Strip about a ½ inch off of each wire. Get that good and snug. Now we'll snap it back in place. There we go. Now it is somewhat debatable as to whether or not it's really necessary to put a loop down and then back up again. So if you don't prefer that, then simply take it down and terminate it straight into the breaker. And that's perfectly acceptable. Worst case scenario, if you have to move the breaker, you can just extend that wire. Now the other thing that I would recommend doing is just labeling the wires as they come into your panel. You can use a short piece of sheathing and just write the location of wherever that circuit is for and slide that over the neutral and the hot wire so that you can keep track of which wires are where. I'm going to install a second arc fault breaker in here. This is a 15 amp. It will be used for a lighting circuit that we're going to do. I just wanted to point out really quick that this outer bushing right here is only required for larger sizes. So on that 1.5 inch, obviously we do need that to protect the wires from getting scraped by the sharp edge of that fitting, but up over here on these 1/2 inch ones it is not required. I believe they start requiring bushings like this on sizes 1 inch and up. My sister just brought me some bubble tea.
Don't spill it.
It's really fantastic. I'll link to where you can get these bubbles in the description below. Just in case you're one of those people who watches this because you think it's interesting, maybe you want to purchase those instead of purchasing one of a wire stripper. Maybe you can click the link in the description and help support the channel just a tiny bit by purchasing some boba bubbles. I don't know what they're called exactly. Anyway, all I have left to do is put the covers on these panels, and we're pretty much done here for now, other than pulling the additional circuits that we will eventually be pulling. Comment down below, let me know if there's anything you would have done differently with this particular panel install, any tips or tricks that you might have. Share them in the comments, and then go through and rate up the ones that you think are good ideas, because this is an excellent place. I always check the comments on videos like this because you can learn so much. There's some really smart people out there. Spend a couple minutes and check that out. If you're ready to continue learning about electrical, click on one of these videos right over here, and we'll start doing that in just a second. I've done videos on wiring a main panel, as well as the individual circuits and different things that you have to know. As long as things keep working the way they are, I'll have another electrical video coming to you every single week. So make sure you get subscribed to the channel, and we'll talk to you in the next one.